All right, what is up, everyone? It's Mr. Rushka here. Today, we're going to talk about graphing linear functions. These are the 3.3 in-class notes. All right, so first thing, we're going to talk about graphing linear functions using the slope of our line and the y-intercept of our line, graphing linear functions by using intercepts, our x-intercept and our y-intercept. And we're going to talk about graphing vertical and horizontal lines. So hopefully this should all be reviewed from Algebra 1, although I guess if you guys are juniors, you probably took Algebra 1 during the COVID year, so maybe it was a little funky there, but hopefully this is a review. So, all right, let's get started. So first we're going to talk about the slope-intercept form of a linear equation right here. Slope-intercept form of a linear equation, okay? Right here, okay? Slope-intercept form of a linear equation, okay? So when our equation is written in the form y equals mx plus b, this is our slope-intercept form right here. Y equals a number times x plus another number, plus just some constant number, okay? So examples would be like y equals 2x minus 4, or y equals negative 4x plus 6, or y equals, I guess, just x plus 1, or even y equals x. That's technically y equals x plus 0. So these are all slope-intercept form right here. Slope-intercept form of linear equations. Now let's talk about why it's called slope-intercept form, okay? Let's talk about why it's called slope-intercept form, okay? So slope-intercept form, okay? The slope, where does the slope part come from? This number m that's right next to x here. This number m, okay? It's a letter here, but it just stands for a general number, okay? Y equals mx plus b. Let's give that, our m, a little red underline here, okay? That little m, that's going to be the number that's next to x, the coefficient of x. So the coefficient of x, right? When our line is in the slope-intercept form, the coefficient of x is the slope of the line. The slope of our line, okay? Right, the slope describes how much y increases or decreases as x increases. So we go from left to right on the x-axis. We'll talk a little bit more about that. The coefficient of x is the slope of the line, okay? So for instance, the line y equals 2x plus 3, right? That has a slope of 2. Slope of 2, because the number right next to x is 2, okay? Or y equals negative x plus 4, right? That has a slope of negative 1, because the number right next to x is equal to negative 1, okay? So the coefficient of x is the slope of our line, okay? That's the slope in slope-intercept form, okay? Now this b here, that I've underlined in green, that's our intercept. What does that mean? Intercept, our x-intercept. So that's our y-intercept. So that's where our graph crosses the y-axis, okay? That's where our graph crosses the y-axis. B is going to be the value of y where our line crosses the y-axis, okay? That's what our b is, okay? So right here, these equations here, right? This second equation here, this second line here, right? That would have a y-intercept of 4. So at the point 0, 4, this line intercepts the y-axis. Similarly, up here in this top equation I'm looking at the point right here, we have 3 here, so at the point 0, 3, this top line crosses the y-axis, okay? We'll see more about that, okay? So that's slope-intercept form, right? Send me an email. Save your questions for Mr. Rushka if you have a question, okay? And now let's talk about the standard form of a linear equation. Standard form, all right? So slope-intercept form up here, right? What do we notice about slope-intercept form? What's special is y is by itself. Y, there's nothing else on the left side of my equation. It's just y. It's only y and y only, okay? Standard form of a linear equation is when our x term and our y term are on the same side of the equation, and our constant term, our term with no variables on it, is over on the right by itself, okay? So that would be like 2x plus 3y equals 5, right? That's in standard form. I have the x term and the y term together on one side of the equation, and then I have my constant term, 5. It doesn't have any variables. That's over by itself on the other side of that equation, okay? So that's the standard form of linear equation. Okay, so that's the distinction between standard form and slope-intercept form, okay? So now let's practice graphing linear equations that are in slope-intercept form. So right here, for part A, I'm looking at part A here under number 1. Okay, I have the line y equals x minus 5. Y equals x minus 5. Okay, so that's in the slope-intercept form. Why? Y is by itself, okay? Let's think about this, guys, okay? The number next to my x is 1, so my slope m, this is slope. Slope equals 1, okay? And then my number here is 5, but it's a minus 5. There's a subtraction symbol right in front of that 5. So my y-intercept is going to be the point 0, comma, negative 5, okay? 0, comma, negative 5. All right, so we looked at our equation here. We looked at the number next to x. That was our slope. We looked at the number without any variables on it. It says subtract 5, so our y-intercept is 0, comma, negative 5. It's that second number there in our ordered pair is the y-intercept, okay? The x-coordinate of the y-intercept will always be 0. It will always be 0, okay? So let's go down here. I'm going to label my x-axis here, my y-axis here. Okay? Let's graph this equation. So I'm going to start, my first step is I plot my y-intercept point. Plot y-int point. Okay, what is that here? That's 0, comma, negative 5. So I'm going to start at 0. I'm not going to go to left or right at all, right? That's why the x-coordinate here is always 0, right? I'm crossing the vertical axis. I don't go to the left or right at all. Then I'm going to go stay here. I'm not going to go left or right. I'm going to go down 5. 1, 2, 3, 4, 5. I'm going to plot that point right here. Okay? My first step. All right? Second step is use the slope to plot a second point. All right? How do I do that? Okay, so you might recall from Algebra 1 that slope equals rise over run. Rise over run, okay? So here my m, my slope, is equal to 1. So that means every time x goes up by 1, my run, right, how much I travel in the x direction, right? Rise is how much I travel in the y direction. Rise, right? We rise in the vertical direction. We run in the horizontal direction, right? You don't run up. You rise up. You don't rise over. You run over, right? Okay, you don't rise forward. You run forward, okay? So every time my x goes up by 1, right? This is my slope, right? This has to equal 1. So every time my x goes up by 1, right here, let me change my pointer color. Every time my x goes up by 1, my y goes up by 1 as well. So all the points of my line here, let me get a green, they're going to start here, okay? We're going to let x, when x increases by 1, our slope tells us that y also increases by 1. Okay? X increases by 1, y increases by 1. Okay? That means the next point is going to be right here. So I'm going to graph that. All right, and then we can just keep graphing. We only need 2 points. Once we have 2 points, we can draw the rest of our line, right? So we need to keep it in line with those two, right? And there you go. Y equals x minus 5. That's my line. Right there, okay? We notice every time x goes up by 1, y goes up by 1 as well, okay? It's like a little staircase. That's because my slope is equal to 1. Okay, let's try that on part B, a little quicker, okay? Let's look here. What's my y-intercept? It's positive 3. So I'm going to graph the point 0, 3. Okay, so let's start at the origin. Let's label my axes. Can't forget to label my axes. Start at 0. Let me go up 3. 1, 2, 3. Okay. There we go. What's my slope? Slope is right here. My slope m equals 2. Right? So that means slope equals rise over run, the change in y over the change in x. Change in y over the change in x. Every time, so slope of 2 means that every time my x goes up by 1, my y goes up by 2. That's what that means. So here, if my x goes up by 1, my y will go up by 2. 1, 2. And so I plot this point right here, okay? Boom. Okay. So I want to make sure, right, between all my points here, x goes up by 1, y goes up by 2, x goes up by 1, y goes up by 2, x goes up by 1, y goes up by 2, 1, 2, 1, 2, okay? It's like clockwork. The hard part for me is drawing a straight line through all of them because I have poor motor skills. I have poor fine motor skills. All right, there we go. That's the line y equals 2x plus 3. All right, so maybe pause if you're having trouble, rewind, slow the video down. That's the line y equals 2x plus 3. Let's go over here to part C. Y equals negative 2x plus 1. So we're going to start just like we have before. Look at this 1 right here. Right, our y-intercept is 0, 1. We start by plotting that. So 0 and then up 1. So we're going to plot the point 0, 1. Okay. And now my number next to x is equal to negative 2. So my slope is m equals negative 2. It's a negative slope now. So what does that mean? What does that mean? Okay, that means every time x increases by 1, my y goes down by 2. It decreases by 2. Decreases by 2, okay? So we're going to start from this point. We go over 1. X increases by 1. Then y goes down 2. Okay, so I'm going to plot this point right here. All right, over 1, down 2, over 1, down 2, over 1, down 2, okay? Similarly, we can backtrack, we can go back 1, up 2, back 1, up 2. Right, so between all my points, right, every time x goes over by 1, to the right by 1, I go down 2, over 1, down 2, over 1, down 2, okay? And let's connect all those, connect the dots from preschool. There's the bane of my existence. All right. Y equals negative 2x plus 1. There we go. There we go. There we are. Okay, so that's how we do that one. Part D. Part D. Part D. Same thing. We look at this number right here. There's a minus 2. So our y-intercept is 0, negative 2. Right, so we start at the origin. We don't go left or right at all. We just go down 2. We plot that point there for our y-intercept. Okay. And then our slope here is 1/2, right? So m equals 1/2. Is 1/2. All right. So here's how this works, okay? So remember, slope is still rise over run. Rise over run, okay? Change in y on top over our change in x, okay? So 1/2, this means that every time x increases by 2, y increases by 1, right? Run, the change in x, underneath our rise, our change in y. So every time x increases by 2, y increases by 1. So what does that look like? Okay, so I'm going to come over here and come down here. So we're going to let our x increase by 2, 1, 2, and then our y is going to increase by 1 when we do that. So there will be a point 1 up here, okay? 1, 2, and then up 1. So to the right 2, up 1. There you go. Right 2, up 1, right 2, up 1. Okay, and we can backtrack down 2 to the left, or down 1 to the left 2, down 1 to the left 2. All right. And we can just kind of connect the dots there. All right. There's our line. Y equals 1/2 x minus 2. There you go. There you go, and now I got my part D graphed, okay? So pause it, slow down, rewind, whatever you need to do, okay? Let's come down here, E equals -4x. E equals -4x. Uh-oh, where's my y-intercept? Where's my y, that's bad. Where's my y-intercept? Well, technically there's a +0 here, right? If there's not a constant term here, there really kind of is. It's just a +0, and they didn't include it, okay? So whenever there's no constant term, it's just going to be 0 right here. So my y-intercept is going to be the point 0, 0. That's just the point that's called the origin. It's just right in the middle here, okay? So let me draw a big, fat blue circle there. Okay, then my slope here, my slope is -4. M equals -4, right? So every time x increases by 1, y decreases by 4, okay? So I'm going to start from my y-intercept, go over 1 and down 4. 1, 2, 3, 4. So I'm going to plot this point right here. All right, and then back 1, up 4. All right, so I have those 3 points. We just draw a line straight through them. Ooh. And there's my line, y equals -4x, okay? So there's part E. Let's go over to part F. Part F, what's my y-intercept? It's +5. So the point 0, 5 is my y-intercept. So I'm going to start at the origin and go up 5. 1, 2, 3, 4, 5. I'm going to plot this point right here. All right. Now my slope. What's my slope here? -3/4 is my slope. -3/4, so I have m equals -3/4. Remember, this is still rise, our change in y, over run, change in x, okay? So every time my x increases by 4, my y decreases by 3. It's a negative. So x increases by 4, y decreases by 3. So I'm going to start here. My x is going to increase by 4. 1, 2, 3, 4. And then my y is going to decrease by 3. 1, 2, 3. So I'm going to plot this point right here. So over 4, down 3. 1, 2, 3. Right here. Those are my 2 points, right? I only need a minimum of 2 points, so I connect the dots. Keep drawing. You need to include your arrows, guys, okay? That signals that this line keeps going on forever. You don't have enough paper to draw the whole thing, because that would require an infinite amount of paper. All right, so let's put our arrows there. So that's our line for part F, okay? So slow down, take a screenshot, pause, whatever you need to do, okay? All right, 8 more graphs, only 8 more. We're good, this is fine. All right, so now we're gonna do graph by finding our intercepts, okay? So we're gonna graph these equations that are in standard form, right? X term, Y term on one side of the equation, and then our constant term over on the other side by itself, okay? What I'm first going to do is find both my intercepts, okay? I'm going to find both my intercepts. So I'm going to have a point where I set x equals 0, and another point where I set y equals 0. Let me use different colors. So x equals 0 and y equals 0, okay? When x equals 0, right, what does that mean? It means I'm on my vertical axis here. If I label my axes, that means I'm on my vertical axis here. X is equal to 0. Right, so this is where I intercept the y-axis when x equals 0. So this right here is my y-intercept. Okay, and then the pink point, right? When my y is equal to 0, that means I'm on the horizontal axis here, the x-axis. Y is equal to 0. I'm on the x-axis, okay? So it's going to be my x-intercept, because that's where I intercept the x-axis, okay? How do I find these other numbers here? Right, my x is 0 here, my y is 0 here. How do I find these other ones? Here's how I do it. I plug in, so let's start with my y-intercept. What's my x-coordinate? My x-coordinate here, it's 0. So I'm going to go over here, I'm going to plug in 0 for x, and then solve for y, okay? So I do 4 times 0 plus 3y equals 12. Okay, that 4 times 0 is 0, so I have 3y equals 12. I divide by 3. Gives me y equals 4. All right, so that's my y-intercept. So I'm going to write that up here, positive 4. Okay. So erase all that work. You can go back and rewind if you need to. All right, my x-intercept, so to find my x-intercept, right, that's where my y-coordinate equals 0. So I'm going to come over to my equation here and plug in 0 for my y. So I get 4x plus 3 times 0 equals 12. And then I can solve for x. So I get 4x equals 12. Since this is 0, divide by 4, divide by 4. Get x equals 12 over 4, which equals 3. So my x-coordinate here is positive 3, okay? So that gives me both my intercepts. And now all I have to do is graph both points and draw a line through them, and now I'm done. So 0, 4, I'll start with that. So 0, and then up 4. Remember, it's x-coordinate, then my y-coordinate. And then I'll do my x-intercept, so go to the right 3. And I'll go up or down it all, right, and there's my line. There's my line. Let me use a neutral color. Oh, it's going to be ugly. I'm not artistically gifted. There's my line right there. All right, it's y equals 4x. Oh, nope, sorry. Nope, pretend I didn't say that. All right, it's going to be 4x plus 3y equals 12. Okay. Part B, same thing, same deal, right? My y-int, I'm going to set x equals 0, so 0 plus 2y equals 6. All right, 2y equals 6. Y equals 3, so my y-int is 0, 3. Okay, my x-int, I set x equal to 0, or I set y equal to 0, sorry. So for my x-int, I have x plus 2 times 0 equals 6, or x equals 6, because this just goes away. So 6, 0 for my x-intercept, right? Don't get this mixed up, guys, right? X-intercept means my y equals 0, and y-intercept means my x equals 0. Don't get that mixed up on a test, okay? So let's label my axes, x and y. I just got to plot my 2 points. So 0, 3, 0, 3, and 6, 0. 6, 0. Let me use pink for that. 6, 0. Okay, and then I'll just use black. So that's line x plus 2y equals 6. All right, another example, part C, x minus y equals 4, right? So let's get that y-intercept. So 0 minus y equals 4. or y equals negative 4. Okay, so y int is 0, comma, negative 4, right? That's because my y equals negative 4. My y equals negative 4, okay? So that second coordinate here is negative 4. Let's get my x int. All right, so x minus 0 equals 4, or x equals 4, okay? So 4, right? X, my first coordinate, x equals 4. So I have 4, comma, 0. Let's plot 4, comma, 0. Don't forget to label my axes. And let's plot 0, comma, negative 4. We just got to draw a line through them. There you go. X minus y equals 4. That's it, right there. Part C. All right, part D. Part D. All right. Let's find our y int. So 3 times 0 minus 2y equals 12. I set x equal to 0 for my y-intercept. All right. Solve for y at minus 2y equals 12. Or that's y equals negative 6. Okay, so 0, comma, negative 6. Let's find my x-intercept. Okay. So that's going to be 3x minus 2 times 0. I set y equal to 0, right? Equals 12. So that goes away. I get 3x equals 12. Divide both sides by 3. I get x equals 4. So my x coordinate is 4, right? X equals 4, so that first coordinate, my coordinate pair, and my ordered pair is 4. So let's label my axes. Let's plot 4, comma, 0, and then let's pop my y-intercept in dark blue, 0, negative 6. All right, and then I'm just gonna draw a line through them. That's all we gotta do is draw a line. All right, kind of curved, but you get the picture. 3x minus 2y equals 12. Okay, so that's it for part D. All right, part 3, we're gonna talk about graphing vertical and horizontal lines, okay? You guys will be pleased to know that this is probably simpler than first, okay? So whenever there is an equation that just involves an x, right? If it's x equals something, this is gonna be a vertical line. Vertical for x equals something, okay? So label my axes. We're going to need a vertical line at x equals 5. So we're going to come 1, 2, 3, 4, 5 to the left. It's minus, it's negative 5. I'm going to plot a point here. I'm just going to draw a vertical line through it. Up and down, okay? Done. X equals negative 5, okay? All right. X equals negative 5. All right. Over here, when my equation is y equals something, I'm going to have a horizontal line. Horizontal. Firmly grasp the net. Horizontal line, okay? Horizontal line, okay? So what does that mean? I go down to 1, 2, and I'm going to plot that point. I'm going to draw a horizontal line to the right, directly to the right, directly to the left, okay? So I do that. Y equals negative 2. Done. Okay? Right over here, part C. X minus 4 equals 0, okay? Here's what happens. First thing I'm going to do is get x by itself, so add 4 to both sides. X equals 4, right? What's this going to be? A vertical line. Vertical, because it's an x equals. X equals. So I'm going to come over here to the right 4. 1, 2, 3, 4. Plot that point. Go straight up and straight down. Boom. And boom goes the dynamite. All right, so we got x equals 4. I should probably keep labeling my axes. X equals 4. Okay, last one, part D, y equals 6 over 5. All right, what is that? It's horizontal. horizontal. Okay, so label my axes. Okay, come up here. I'm going to count 6/5 above the x-axis. Okay, so it's just 1 and then like 1/5 of the way to the next line right here. So it's just a little bit above that first line. So we're going to graph that, and then I'm going to draw to the right, draw to the left. Boom, done. Y equals 6/5. Okay. There we go. So pause it if you need to. Slow down the video if you need to, but here's every page. All right, so come ask your questions in class if you don't understand this, okay? This stuff will be on the test. All right, you guys take care. Yeah, again, ask me questions.